Hello learners, this is the third lecture in set theory on algebra of sets. In this lecture, you will learn about intersection, union, difference, symmetric difference of sets and complement of a set. Let us start with intersection of two sets. If A and B are two sets, then the set of all elements which are common to both A and B is called the intersection of the sets A and B, and it is denoted by A intersection B. It is the set of all the elements which are both in A and in B. Note that A intersection B is a subset of A and a subset of B. Intersection of A and A is A. Intersection of A and empty set is empty set. If A is a subset of B, then A intersection B is A, and if B is a subset of A, then A intersection B is B. Two sets A and B are said to be disjoint if their intersection is empty. Let us see some examples. Now, A is a set with elements A, B, C. B is a set with elements B, C, D, E. Here, A intersection B is the set of elements which are common to both A and B. B and C are the elements which are there in both the sets A and B. And observe that intersection of A and B is a subset of A and also a subset of B. In the second example, there is no element common to both A and B. Therefore, their intersection is empty. Therefore, A and B in this case are disjoint sets. Now, in the third example, every element of B is an element of A. So here B is a subset of A. And if you see their intersection, it is B again. The elements common to both A and B are 9, 18, 21. So in the case intersection of Z and set of natural numbers, it is set of natural numbers because every natural number is an integer. Now, union of two sets. The union of two sets A and B is the set of all elements which belong to either A or to B or to both. So A union B is set of all elements which are in A or in B or in their intersection. Note that both A and B are subsets of their union. Union of A and A is A. Union of A and empty set is A. If A is a subset of B, then A union B is B. If B is a subset of A, then A union B is A. Let us see some examples. Here A is set with ABC, B is the set with BCDE. Now the elements which are in A, elements which are in B are in both constitute A union B. So A union B is a superset of A and B. Here observe that A is a set with elements 3, 6, 9, 12, 15, 18, 21. B is a set with elements 9, 18, 21. And see that B is a subset of A. Means every element of B is an element of A. And if you write A union B, it is A. Now, union of set of integers and set of natural numbers is set of integers because set of natural numbers is a subset of set of integers. Now, coming to the difference of two sets. The difference of two sets A and B A minus B is the set of elements which are in A and not in B. If we write B minus A, it is the set of elements which belong to B and does not belong to A. Note that A minus B is a subset of A and B minus A is a subset of B. Let us consider the sets M and N. If we write M minus N, we have to write the elements which belong to M and which does not belong to N. When we write N minus M, we write the elements which are in N and which are not in M. You can go through the other examples. Now, for the sets A and B here, it is given the union of A and B, intersection of A and B, difference of A and B. You can go through these examples and understand. The complement of a set. The complement of a set A in a set U is the set of those elements of U which do not belong to A, and it is denoted by A prime. So A prime is those elements of U which does not belong to A. It is just U minus A. Now note that union of A and A complement is U, intersection of A and A complement is empty set. Also note that if A is a subset of B, then complement of B is a subset of complement of A. Also, complement of empty set is the universal set and complement of the universal set is empty set. This is quite interesting. Complement of A is A itself. You can check this example where you have here U as a universal set of the sets A, B, C. When we write A complement, it is just U minus A, and B complement is U minus B, C complement is U minus C. This is another example wherein you can write complements of the given sets. Now, symmetric difference of two sets. If A and B are two sets, then their symmetric difference is union of A minus B and B minus A. See, here in this example, A is set with 1, 2, 3, 4, 5. B is a set with 4, 5, 6, 7. When we write A minus B, it is the set of elements which belong to A and which does not belong to B. B minus A is the set of elements which belong to B and which does not belong to A. So now if we write the union of A minus B and B minus A, it is the set of elements in A minus B or in B minus A or in both. So here union of A minus B and B minus A is the symmetric difference of A and B, and it is A delta B. You can try to understand this second example. Now here are few important laws which can be proved and verified. Commutative laws, associative laws, distributive laws, identity laws, complement laws, idempotent laws. Absorption, involution, De Morgan laws. The De Morgan laws are very, very important. Thank you.